Hey guys, welcome back to KY tutorial. Today I'm going to show you how to supervise a data and produce accuracy assessment using ERDAS. Without further ado, let's get started. First, open ERDAS software. Then open the data you have downloaded or you have taken from somewhere else. For my data, I have taken from MyStat and it is a spot 5 data. Then change the color of the band 1, band 2, band 3 to red, green, blue respectively. Up next is to georeference the data. Select control point at the top bar and you have to pick where is your data come from. For this one, it's in spot 5. So select spot 5 and okay. My reference system for selecting GCP is uh, Google Earth Pro. Okay, I'm going to key in manually. So open up your Google Earth Pro. It takes time to load, okay? So just be patient. To georeference the data, we have to find the exact same position at ERDAS and Google Earth. I knew my data is from Penang, so I'll just type in Penang at Google Earth. And there you go. It's Penang. Welcome to Penang. Okay, zoom into the same point in ERDAS and Google Earth. Then select the GC icon in ERDAS, click on the point, and do the same thing for Google Earth. Copy the longitude and paste it at the X reference and latitude for Y reference. My coordinate is in decimal degree form. Okay, repeat the same thing for the next GCP. I'm going to do for GCP. I'm gonna just speed up the process a little bit because it takes too long. Okay, so after done selecting all the GCP, select the sum icon on top to check the RMS error. My RMS error is 0.0047, which is pretty accurate, so I'll just leave it. After you have satisfied with your RMS error, save the data. We also call it as resample. For this data, I am using nearest neighbor method. So I'm going to save this resample data as nearest neighbor. Nearest neighbor. Okay. And you can close it. Yeah, you can save the model as well just to backup. In case you want to reuse the data, you can just open the model that you have saved and add more GC point to it. Of course, you can save your GCP point where you have created just now. Remove the raw data that you have insert at the first place and insert the resample data that you have did just now. You can see that the data is now tilted, which means that the data has georeference. And again, change the band color 1, 2, 3 to red, green, blue respectively. Next is to select training site. Select supervise signature editor. You can minimize the bar first, you'll use it later. Select polygon and to the first training site. I'll start with shallow water first. After select, key in the polygon in the signature editor. Repeat the process again for all the training classes. It is recommended to select 5 or more pixels for classes. This is to make sure that a same class we have different pixel so that we can take the average to classify the training site later on. So after you have done selecting all the training site, we can now merge all of them. Select all the classes that you have picked and merge. Delete the selected and rename the merged classes. I'll rename it as shallow water. You can change the color of the classes depends on what is the exact classes. Oh no, depends on what is the exact color for the place in reality. I'll repeat all the process again, but then I will fast forward it because it really takes too long. So after I've done classify all the classes, I'll save my signature editor in a folder that I've saved just now. Okay, I'll type in SIG. Okay, next is to supervise my image. Select classified, supervise, save the folder, save the data to the folder you want. I'll name it as supervise. Okay, I'll change it to minimum distance because I'm doing nearest neighbor. Let it run for a while. So after it has done process, open up your supervised image at the viewer. Right click at the supervised image and you can examine the attribute data. As you can see, the color classes is the classes that I have classified just now. So now I'm going to proceed with my accuracy assessment. Select Supervise Accuracy Assessment and insert your supervised image. After you have inserted your supervised image, create random point. I'll just create 30 point. This random point is where ERDAS will create for you. Show all the point that created on the viewer. So now all the point that ERDAS created will show on your data. What I will do now is I'll remove the unclassified classes. I'll first show the class value and select a random row, right click criteria, class equal to 0, select and remove them. So after I've do it right, it only show all the classified classes. And now I'll open up my Google Earth again for my reference. What I'm going to do now is enter the coordinate value where ERDAS has created just now to search the real location and examine what is the reality in the real world. To check out the the object at the real world and to determine whether I classified them correctly. Okay, so for my first coordinate, it shows that it is shallow water in reality. So I'll just key in the class number of shallow water at my reference. So it is 14. So I'll just key in 14. You can see that it is exactly same with the class that I have created just now. So repeat all the point again with the same steps. So after you have generated all the reference point, we can now proceed with the accuracy assessment. To generate the accuracy report is quite straightforward. You just have to select option accuracy report, and this is how you generate your accuracy report. For my accuracy report, you can see that the percentage is as high as 95%. So it's pretty accurate and I'm satisfied with my result. So I think that's all for the tutorial today. Thank you everyone for listening, and remember to hit the like button, subscribe and comment. Thank you.